All right. Today we're going to talk about operations on complex numbers. So adding them, subtracting them, and multiplying them. We're not going to divide them because dividing is something completely different that we're not going to cover right now. So before we start, there's a couple things that you need to know. You know that I is the square root of -1. We talked about that the last time. So I to the first power would just be I, because that's the square root of -1. Well, so now, what if we had I squared? We know that I is the square root of -1, and so I squared would be the square root of -1 times the square root of -1. And recall that, let me use one that's not negative numbers, the square root of 3 times the square root of 3 is the square root of 3 times 3, which is the square root of 9, which is 3. So the square root of 3 times the square root of 3, forget all this, is 3. Similarly, the square root of 2 times the square root of 2 is 2. All right, so the square root of -1 times the square root of -1 is -1. So I squared is -1. Actually, let's do that in a different color so we can see it. Well, then I to the third power would be the square root of -1 times the square root of -1 times the square root of -1. Well, we know that the square root of -1 times the square root of -1 is -1. And we know that the square root of -1 is I. So I to the third power would just be -1 times I, which is -I. Let's do I to the fourth power. That would be the square root of -1 4 times. You know that the square root of -1 times the square root of -1 is -1. Again, the square root of -1 times the square root of -1 is -1. -1 times -1 is a positive 1. Let's do I to the fifth power. I'm hoping that you start to see a little bit of a pattern here. If you know that if you know that I to the fourth power is 1, you would have 1 times the square root of -1, which would be I. All right, and if you can't see that, write it out. There's nothing wrong with writing it out. You would be multiplying this 5 times. And you know that I always just circle groups of 2 just because it helps. So you have -1 times a -1 times the square root of -1. -1 times -1 is 1. The square root of -1 is I. 1 times I is I, which we got up here. I to the sixth power. Well, if I to the fifth power is I, you would have I times the square root of -1. Well, how do we do that? Let's just write it out and see. -1 times -1, because you can't have I squared as your answer, but you do know that I squared is -1, so that should be what we come up with. So we multiply this 6 times, and you know that that's going to be a -1, that's going to be a negative 1, and you know that that's going to be a negative 1. So you have negative 1 times negative 1 times negative 1. Negative 1 times negative 1 is a positive 1. Positive 1 times negative 1 is a negative 1. Because you have I times I, because negative 1 is I times I is I squared, well, you know that I squared was negative 1 over here. So it's just a matter of finding the patterns. And which ones of these are real numbers? Well, this is not a real number. I to the first power is not a real number. Negative 1 is a real number. So I to the second power is real. I to the third power gives you negative I. That is not a real number. I to the fourth power, we ended up with 1. That is a real number. I to the fifth power was I, not a real number. I to the sixth power is negative 1. That is a real number. So hopefully you can see if it's just the I, if there's an even exponent, you do end up with a real number. But I'm not sure that that's always going to be the case. So let's go ahead and start. I'm not really worried about the additive inverse. That's not the important piece of this. So I'm going to skip over that. But not so much that I take everything away. So let's start with adding complex numbers. All right, when you add complex numbers, it's just like adding algebraic expressions. You just combine the like terms. So the first thing we want to do is add the real parts, and then we're going to add the imaginary parts, and we write our answer in standard form, that a plus bi. So we'll write the answer in standard form. So let's go ahead and do this. If we have 3 plus 2i plus the quantity of negative 4 plus 9i, we add the real parts, which is 3 plus a negative 4, which is a negative 1. And then we have 2i plus 9i, which is a positive 11i. That's all there is to it. Add the real parts, add the imaginary parts. The quantity of negative 6 minus I plus 3 plus 8, the quantity of 3 plus 8i. Add the real parts. Negative 6 plus 3 is a negative 3. A negative I plus 8i is a positive 7i. And there's your answer in standard form. Go ahead and try 3 and 4. Pause it now, and then I'll come back and have the answers there. Hopefully, for number 3, you got 11 plus 8i, and for number 4, you got 10 minus 4i. Nothing to it. Add the real parts, add the imaginary parts, write your answer. So let's take a look at subtracting. Subtracting is the same, all right? You're going to distribute the negative, which is the same thing as you're just distributing this negative sign, which is like a subtraction sign. You're going to combine like terms. So we're basically adding, and then you write your answer as a plus bi. So we have 5 minus 2i minus the quantity of 3 minus 4i. Well, this actually ends up looking like 5 minus 2i plus a negative 3, because we distribute that, and we distribute it there, so it's plus 4i. Combine your like terms, so 5 plus a negative 3, and then you have a negative 2i plus 4i. Write your answer in standard form. 5 plus negative 3, 5 minus 3 is 2, and a negative 2i plus 4i is a 2i. Let's go ahead and let me give you some more to do. All right, here's 3 more. The quantity of 6 plus 8i minus 4 minus I, the quantity of negative 1 plus 3i minus the quantity of 4 plus 9i, and the quantity of negative 2 minus 6i minus 9 plus I. Go ahead and pause and then work them out, and then when you come back, I will have the answers. Hopefully these are the answers you got. 6 minus 4 is 2. 8 minus a negative 1 is a positive 9i. Negative 1 minus 4 is a negative 5. 3i minus 9i is a negative 6i. Negative 2 minus 9 is negative 11. Negative 6 minus a negative I is a negative 5i. All right, so let's move on to multiplication. Same thing as adding and subtracting. You deal with the real parts, you deal with the imaginary parts, and then you simplify. Very important for you to remember that I squared is equal to negative 1. And then as we get further into it, you may come up with some I cubeds and I to the fourths or I to the sixths. So just remember the little pattern of numbers that we dealt with in the beginning. So first thing is we multiply the real parts. Then we multiply the imaginary parts. And we simplify. So our real parts, 2 times negative 4 is a negative 8. I times I. Remember, I times I is the square root of negative 1 times the square root of negative 1, which is negative 1. So it is negative 8 times a negative 1, which is a positive 8. This is a real answer. You get a real number if you multiply 2i times negative 4i. Very important to remember. So the same thing here. Let's take a look at 3i times 7i. 3 times 7 is 21. I times I is I squared. Remember that I squared is negative 1. So 21 times negative 1 is negative 21. Again, you get a real answer. I'm going to come back with some more for you to work on, and then we'll pause it and you can work on them. Let's take a look at these three right here. 4i times 3i, negative 6i times 3i, and 3i times 10i times negative I. So be really careful with this one. Go ahead and pause it and then see what you come up with. Here are your answers. 4i times 3i is negative 12. Negative 6i times 3i is a positive 18. That negative. And 3i times 10i times negative I is 30i. So I would imagine that maybe some of you got tripped up with that one. So let's take a look and see how we ended up getting that. You've got 3i times 10i times a negative I. Well, this should not have been a problem. So you have negative 30 times negative I. This is the same thing as negative 30 times the opposite of the square root of 1. Well, this is the same thing as saying negative 1 times I. Negative 1 times the square root of negative 1. You go in order from order of operations from left to right. So negative 30 times a negative 1 is a positive 30 I, because the square root of negative 1 is I. All right, so now let's take a look at our multiplying binomials. And I'm going to erase all this because we may need a little more room than what's on here. But when you multiply binomials, it's the distributive property. We, or you, have called it FOIL. you're going to simplify and write as a plus bi. So we were doing this when we started factoring our quadratics. You multiply the first terms. So we have 3 times 7, which is 21. And then we have 3 times a negative 4i, which is a negative 12i. And then we have 4i times 7, which is 28i. And we have 4i times negative 4i. So 4 times negative 4 is negative 16. Whoops. And then I times I is a negative 1. So this is actually plus 16. And then you simplify. Whoops. All right. 21 plus 16 is 37. Negative 12i plus 28i is a positive 16i. This is not a real number answer because you have that. There's no way to pull that I out of there. So now let's try the next one. We have 8 times 4, which is 32. We have 8 times a negative 6i, which is negative 48i. We have a negative 9i times 4, which is a negative 36i. And we have a negative 9i times a negative 6i. Negative 9i times negative 6i. Negative 9 times a negative 6 is a positive 54, but I times I is a negative 1. So that's a minus 54. And now we simplify. 32 minus 54 is negative 22. And a negative 48 and a negative 36 is a negative 84i. Again, another non-real answer because we can't get rid of that I. All right, I've given you a few problems here to work on. You should have no problem with these first two. When you get down here, be really careful, all right? You cannot distribute exponents over addition or subtraction. You actually have to expand it. So this is the same thing as 6 plus 2i times 6 plus 2i. You cannot distribute exponents over addition and subtraction. You cannot distribute exponents over addition and subtraction. So don't do it that way. All right, so go ahead and pause it and work on these next couple problems, and then I'll come back with answers. All right, and here are our answers. This is the answer to the first one. I went through and actually worked it out and showed you each step, and then took that last piece, that negative I times I is a negative I squared, which is negative 1 times I squared, which is negative 1, which is a positive 1. So if you want, you can pause this and then go through and look at the work that was done to get these answers if you didn't get them correct. And that is it for this. We will have an activity to do in class tomorrow.